Hello everyone! This is the next part of tutorial videos dedicated to animal system. And in the last part we created a logic so that we can feed our fox. We can drop an item to it and it will move and eat it. Now let's extend this logic a little bit. Now we have such problem. Let me show you. If I will start project and move into visibility of a fox, it is interrupted. And if I will stay here, it will be interrupted for all the time. If I will go away for a walk for an hour to drink a beer, it will still stay away here. And that's not good. It should be interrupted for some time, and if nothing happens, it should run away. So if I run, it runs away, but if I'm doing nothing, it will stay there forever. Now, let's open an animals and let's think how we're gonna do this. Let's open a component and we have SAI behavior. Nope. SAI behavior config. Also no. Let's open a component. And let's open uninterrupted. So we have an interruption time, and on this interruption time it checks whether it should run away or whether it should attack us. And every animal in our game, let's open a fox for example, let's open a component, it has an interruption time. So the by default logic that we've created in the first series, it was interrupted for 2 seconds and then ran away. But now we are checking whether what should it do after an interruption time ended. Whether it should attack, whether it should run away. And now we can have a case when none of these conditions is passed. So should attack condition is not passed and should run away condition is not passed. And it stays in interruption state forever. So let's add a new variable here. We have an interruption time. And let's have something like default interruption behavior. And let's make it float. Oh no, not a float, it's gonna be an AI behavior. Well, one thing that I would like to do, I want to, as you can see in Fox, we can see a lot of variables here that should not be edited, like runaway actor, behavior config, interruption actors, default interruption behaviors. They should not be edited. And let's make them private. I'm gonna make an interruption timer private, runaway time to private, no, not private, runaway timer to private, attack timer to private, animal to private, runaway actors to private, behavior private, not private, behavior config and interruption actors private, and default interruption behavior should be public. So this is default interruption behavior, and interruption time is how often this check is happening. And we should have something like max time in interruption state. And let's make it float. And by default, let's make it 10 seconds. So, how it gonna work? We're gonna, if none of this condition is passed, then we're gonna end max time and interruption state is already exceeded, wherefore we are running this default interruption behavior forcefully. Doesn't matter whether one of these conditions is passed, we're gonna run this behavior. So where it should happen? It should happen here on false of run away. So if first condition is not passed, then we're going and checking if runaway condition is passed. If it is not passed, we're reaching this destination. And here we're gonna check. We're gonna have some branch. And if it is true, then we're gonna stay in interruption state. Well, let's make new variable and call it current interruption state time. By default it is 0, and let's make it private. And it will be increased every time onInterrupted function called. So let's open onInterrupted function here, and we're gonna get current interruption state time, add add interruption time, and set it. Not get, set. Connected here, like this. And here we're gonna check if max interruption state is greater than current interruption state time. If it is greater, then, well, we're starting interruption timer again. And if it is not, we're gonna set a default interruption behavior. And let's add on interruption, no, we will not add an interrupted function, some force flag. And then we're going here, getting our default interruption behavior and switching on it. Switch. If it is idle, then we're calling set behavior to an idle. And behavior config instigator in this case is not needed. If it is attack, then we should call this part. So we have to plug it somehow here. If it is run away, somehow here, and if it is interrupted, we should set current interruption. In every case, we should set current interruption state time to 0, back to 0, like this. And on interrupted, we're gonna start this. So now let's try to connect it somehow so that it will not look very ugly. So on attack, we're gonna do this. Now let's add some pins. I don't know. No. The problem now is that we cannot connect it. Well, maybe we should create some functions. Let's create a function called setAttackBehavior. And what it's gonna do? It's gonna do this part. Just cut it from here and call setAttackBehavior like this. And paste everything that we've copied here. Well, next function is gonna be set run away behavior. Go into uninterrupted, cut this, and paste it here, like this. Well, we need to provide a behavior config instigator, like in setAttackBehavior, copy it from here and paste it from here, and plug it in. Now back on interrupted. Oh, we should call this function set run away behavior from here. Now back to here, we should call set run away behavior, set attack behavior, like this. So, and connect attack here and run away here. And interrupted is connected to here. I will leave it like this. Maybe I will move it a little bit to the right. That's fine for me. Well, that's it. Now let's open our bpfox, compile it, and change needed parameters. Okay, max time in interruption state is now 10 seconds. Let's make it 15 seconds. And default interruption behavior is gonna be run away. That's all. Now let's start. And well, it saw me, it ate a food, but its behavior is still interrupted. And it should run away from me in 15 seconds. Let's wait a little bit. Yeah, so that's already fine. And this video is short, so I think that we will be able to create one new feature here. And we should add some hunger parameter to our fox. Oh, not a hunger parameter. Every animal, let's open our BP animal parent. Every animal should have a time when it ate something at last. So let's add a new variable and call it last eating time. And it's gonna be a float. And by default, it is 0. So what I want to do, I don't want the fox to eat if it has ate some time ago. Also, every animal should have some eating rate. For example, maybe we should do it with a hunger, I think. Yeah, I think that every animal should have some hunger variable, some hunger parameter. Let's call it hunger. And it is gonna be a float from 0 to 100 or to 1 as you wish. And by default, I wanna use from 0 to 1. By default, it will be 1. That means that it's not hungry. Let's add a description. 1, not hungry. 0 starts dying. But this thing will be used only for an animals that are already tamed, because I don't want an AI that just moving through a forest to die from a hunger. They are not eating something in the forest, so it should not affect them, only if an animal is tamed. And let's add a new variable called isTamed and make it boolean. By default, it is false. Now it will be always false. Well, let's open our behavior tree. And we are calling it when we have found some tame, but we should also call it only if a hunger, if our animal is hungry. If it is not, then we should not call it. So let's change our service find tame around, and we should define whether it should even search for it. So let's move everything in event tick AI. Okay, let's move an event tick AI by itself to the left, like this. And what we're gonna do? What's happening here? Okay, we're gonna get a control pawn and cast to BP animal parent. And get its hunger. Hunger, and check if it is in range. In range. Well, we want to search for a tame only if hunger is in range of, for example, 0 to 0, 0.8, for example. Let's add a boolean. And if it is true, then we're running this EQS query and searching for a tame. If it is false, then we're gonna nullify our tame if it is found already. We're gonna get tame key and set value as object to nothing, like this. And what we're doing here, okay, nothing. No, no, no. We also should run this event on activation. We should run this EQS query also only after this check. So we should just copy and paste this check, by the way. Oh, we already have animal parent here, so I'm gonna just copy it, paste it here. And we need to connect this animal parent to a target. Let's make it a little bit cleaner. And if hunger is in this range, then we're calling this EQS query. In other case, we're doing nothing because it's only an activation. Or no, it can be activated in a few places, so we're also nullifying our blackbird value. Well, now our animal will not eat because our hunger is always 1, but it should be decreased sometimes. So let's add a new function called start decreasing hunger. And let's add a new variable called hunger decrease rate. Let's make it float. And by default, for every animal, it's gonna be 0.1. And let's start it in a begin play. So on begin play, we will start some timer, set timer by function. Set timer by function, it's gonna be every 10 seconds, I think. It's gonna be looping and it's gonna call start decreasing, or not start, let's call decrease hunger. Decrease hunger. Oh well, and decrease hunger is gonna get hunger minus subtracting hunger decrease rate and setting a new hunger, set hunger, like this. Also, we're gonna do this only if an animal is... No, it should be done every time. So that's it. Now our animal also after eating, its hunger should be increased. So we have a task, eat tame. Let's open it up. And here we're getting a blackbird key and destroying the nectar. Also, we should get a pawn and let's call a function eat tame. And it will just set hunger to 1. Also in a timer on decrease hunger, we should clamp this value, by the way, because it should not be a negative value. We should clamp it between 0 and 1, like this. And let's open it tame and get control pawn, cast to BP animal parent. And call function eat tame. Let's open it up. And as you see, it didn't navigate to this tomato and ate it, because its hunger is at 1. So let's wait a little bit. It's gonna run somewhere. Let's run to it, and we're gonna drop a tomato because now its hunger should be at some value below 1. Oh, it saw me. Oh no. I'm gonna drop a tomato here. Oh, my widget is a little bit. Okay, eat it now. Okay, and now it ate a tomato and decided to run away. So that's it for this video. Thanks for watching. Hope it will help someone.